Let's dive into Trig Identities Day 2. So we're going to continue embracing some new methods of simplifying and being able to break down these trig identities. In this example, number 1, we have A, B, C, D parts, and I'm actually going to work backwards on this somewhat. We will begin with part D because this one is very similar to the problems that you did when you guys started out these sections. So tangent can be broken down into sine over cosine. So we're going to write sine theta over cosine theta. Always break down everything. Hold off on breaking down sine and cosine. Cosecant also can be rewritten as 1 over sine theta. And cosine is that trig function that I told you to leave alone. It's very rare that we rewrite cosine in terms of 1 over secant. Okay? So here we have 3 rationals that are multiplying that have numerators and denominators that are common. So we are able to cross those out and simplify and end up with just 1. The sines crossed out, canceled, cosines canceled. We are left with a 1. Okay, let's go do secant squared theta minus 1 over secant squared theta. So when you come to your formula chart, secant squared theta minus 1 is right here in the center, and we can see that secant squared theta minus 1 is the same thing as tangent squared. So let's go back to our problem and substitute. Tangent squared theta over secant squared theta. So let's break these down even further. We know that tangent squared theta can be rewritten. Tangent is just sine over cosine, but since we have our tangent being squared, we must make sure to adjust our formula to be sine squared over cosine squared theta. And then that is being divided by secant squared. If you look again on your formula chart, secant squared is 1 over cosine squared. So let's go ahead and do that. So 1 over, that's going to drive me crazy, over cosine squared theta. Okay. And once we see these two rationals have common denominators, we can cancel those and be left with sine squared theta over 1, which simplifies to just sine squared theta. Okay. Now, this is not the only way that this particular problem could have been simplified. And I want to show you a different technique because at times it will come handy with problems that are similarly written and set up like this problem. So I'm going to come over here and rewrite our given problem. Secant squared theta minus 1 over secant squared theta. Okay, so what you can do is rewrite this rational as 2 different rationals by breaking it up like so. Secant squared theta is being divided by secant squared theta. Put the minus, that's the operation, the arithmetic operation, but we also must make sure that 1 also is being distributed in the division sense with secant squared theta. All right, and at times it's a bit of a cheesy way to remember, but I tell students, I call this like my butterfly effect. Okay, you can see, I'm going to make my little butterfly here. Very poor drawer, but you know what I mean. Okay, so if you think of this as like a butterfly effect, we're breaking it up and splitting it up so that we can simplify it in this fashion, okay? So if I come back and I simplify secant squared theta over secant squared theta, that's going to be a 1. 1 divided by secant squared theta, well, we know 1 over secant is cosine theta. Make sure you have your formula chart handy. So 1 over secant squared theta is 1 over cosine squared theta. And once again, if we go look for 1 minus cosine squared theta in your formula sheet, you can see right over here, 1 minus cosine squared theta is the same thing as sine squared. So 2 different methods of approach, but yet they both yield the same answer. Okay, so what I would like you to do is use this butterfly method that I'm showing you here to split up your fractions. This particular problem, whoops, I don't know where my problem went. I kind of messed up here. Oh, I see what I did. I wrote the problem in the wrong area. Okay, so sorry about that. So this particular problem, I want you guys to write it out and simplify it for part A. So here we go. I just wanted to make sure that I didn't confuse you. I just rewrote the problem in the correct spot. So again, I would like you guys to do the method that I just showed you guys, but apply it to part A. So go ahead and apply that butterfly approach so that we can break it up and start solving. So do that. Okay, so let's see if you broke that up. So tangent over tangent theta plus cotangent theta over tangent theta. Well, tangent theta over tangent theta is just a 1. Cotangent theta, well, there's so many ways you could rewrite this. I'm going to write this in red because I want to make a point. Some students prefer breaking up cotangent as cosine theta over sine theta, and then they break up tangent as sine over cosine, right? And then once you do that, you can multiply by the reciprocal and go from there. Also, you can do it this way, which is what I'm going to do right now. I can rewrite cotangent theta as 1 over tangent theta. So again, be looking at your formula. And the tangent theta, I'm just going to leave it as is so that it kind of matches with what I just wrote. So when I do this, 1 over tangent theta plus over tangent theta, I can multiply by the reciprocal and go 1 plus 1 over tangent theta times the reciprocal of tangent, which is also 1 over tangent theta. That simplifies to 1 plus 1 over tangent squared theta. 1 over tangent squared theta is 1 plus cotangent squared theta. And then if you go look at your formulas, 1 over cotangent squared theta is the same thing as cosecant squared theta. So let's go put that back in our problem. Okay, you will notice that if you took the approach that I wrote in red, you would end up with the same answer. Okay, you would end up with the same answer. Let me show you how. So over here, I'm going to erase this part now that you've followed along with me. And let's multiply by the reciprocal. So it's 1 plus, we have cosine theta over sine theta. And we're going to multiply by the reciprocal, which is cosine theta over sine theta. Now cosine times cosine and sine times sine ends up being 1 plus cosine squared theta over sine squared theta. And we know that 1 plus cosine squared over sine squared theta is the same thing as 1 plus cotangent. Sorry. And as you realize, this was the same trig function we had before, and it also is equal to cosecant squared theta. Different approaches, okay? All right, let's go on to the next part. Okay, so I want us to take a moment and look at the formula chart. I want you guys to realize that all right here in this section right here, we have problems that are all subtracting. So whether it's 1 minus cosine squared or secant squared theta minus 1 or cosecant squared theta minus 1, every single one of these are subtracting, but there's something special about them. And what's special about them is that they are all difference of squares. Difference of squares. And if you recall, this was a special factoring form where you guys can have two numbers that are subtracting, difference of squares, that can be rewritten as a product of a minus b times a plus b. So why do I share that? Because I want you guys to please recognize that every single one of those that I circled previously can be rewritten. So for instance, sine squared equals 1 minus cosine squared, where we are going to pretend that 1 is the a squared and cosine squared is the b squared. That can be rewritten as, well, the square root of 1 is just 1, minus the square root of cosine squared is cosine theta. So 1 minus cosine theta and 1 plus cosine theta, which is that a plus b, a minus b situation. Same thing with this next one. 1 minus sine squared can be rewritten as 1 minus sine times 1 plus sine theta, that is. Tangent squared theta, not only is it secant squared theta minus 1, you can write it as secant theta minus 1, secant theta plus 1, and so forth. You can do that for the other three. So this proves to be powerful for problems like we have in part B. So let's look at part B, okay? Part B here has cosine squared theta over 1 minus sine theta. So what I'm saying here is that if you look at your chart, cosine squared theta is the same thing as 1 minus sine squared theta. And I'm going to divide, and I'm going to bring over the 1 minus sine theta, which is part of our problem, okay? Now, these cannot cancel. Please don't attempt to cancel these because these are subtracting, okay? The numerator and the denominator is subtracting. But what I want you to recognize is that this here is a difference of squares problem. So I can rewrite 1 minus sine squared theta as a product of 1 minus sine theta times 1 plus sine theta. And notice that when I write down the denominator, I'm going to notice that there are some common factors that I can now cancel, and I can reduce to 1 plus sine theta. And so this here is my final answer. Okay, moving down to the center of your page. When verifying identities, I want you to ignore the simpler looking side of the equal sign. Okay, ignore the simpler side of equal sign. And then I want you to simplify the other side. So, in this problem, in example number 1, notice that the 1 is the side that I am going to choose to ignore because it's very obvious that it is the simpler looking side. I'm going to work with the left-hand side and break it down wherever I can. Sine theta, don't touch it. Cotangent theta is the same thing as cosine theta over sine theta. And secant is 1 over cosine theta. And when I go to simplify, I notice that it all reduces to a 1. And the 1 is what I ignored, and then that's how I can prove my verification of the identity. Let's do that again. So in this scenario, neither one seems to be pretty obvious on which is the simpler looking side. So I'm just going to pick to ignore. Let's do the left-hand side this time. Okay, I'm just going to pick to ignore this side. So I'm going to ignore. And this is like saying that this is my answer key, so to speak. Okay, whatever I ignore, that's my answer key. So I'm starting to work with 2 cosine squared theta minus 1. And I want it to end up being what it is in that red box. So cosine squared theta in my trig function formula sheet is 1 minus sine squared theta. And then the minus 1 comes down. So I substituted this. This is what I replaced. I just replaced cosine squared theta with what it's equal to in the formula sheet. I am going to distribute because my final answer in that red rectangular box has no parentheses. So let's get rid of these parentheses. 2 minus 2 sine squared theta minus 1. And then I notice that, whoops, didn't mean to do that. I notice that the 2 and the 1, negative 1, are like terms. So I can combine them to a 1, bring over the 2 sine squared theta. And this is where I am going to stop because this is what I ignored at the beginning of my problem. So check mark, I have verified it. Okay. Don't worry about this. Let's go on to the next page. All right, so over here at the top, we have another verification of identity. We are going to ignore this side. Okay. And our goal is to get cosecant squared theta minus cosine squared theta times cosecant squared theta. We want to get it to become a 1. So here is me reminding you guys of another factoring method, just in case you have forgotten about it. The greatest common factor, which is what we like to shorthand call GCF. Okay, we find the greatest common factor in this problem. So what I want you guys to notice is that if you look at this problem, I notice that this term is common in both cosecant squared. So I need you to identify whatever your greatest common factor is, and then you write it down. Whatever you see is in common, you write it down. So that is the GCF. And then after you write the GCF, I want you to put open parentheses because your goal is to factor, and factor just means to undistribute, okay? Undistribute. So what you're going to do is whatever you identify to be your GCF, I need you to go divide it out so that you can figure out what the remaining factors are. So I'm going to divide both terms by cosecant squared theta because that's my GCF. Well, cosecant squared theta divided by cosecant squared theta, that's just 1. I'm going to put my minus. And then this right here, cosine squared theta times cosecant squared theta over cosecant squared theta, well, those are going to cancel. So I'm just left with cosine squared theta. Okay, and that makes sense because if I multiply this times this, I do get my original problem. And if I multiply this times this, I get this part of my original problem. So I didn't change anything. But what I gave myself an opportunity to do, well, cosecant squared theta, this right here, I'm going to rewrite it as 1 over sine squared theta. And then 1 minus cosine squared theta is one of the trig identities on your formula sheet. And you'll notice that 1 minus cosine squared theta is sine squared theta. Again, once I cross those out, I end up with a 1. And yay, that's exactly what I wanted, because that's what I crossed out at the beginning. Last but not least, okay, when it comes to problems like this, please, just like you've done in the past, when you see distribution, you are still going to multiply, okay? Now, I want you guys to notice, though, in this particular problem, this is an A minus B, A plus B scenario. So we're going to take the shorthand. Sine times sine is sine squared theta minus the cosine squared theta, because we know that A plus B times A minus B just means A squared minus B squared, okay? Now, they did tell us in this problem to leave it in terms of sine squared. So they do not want anything other than sine squared in our final answer. So we can remedy that by bringing down the sine squared, because that's acceptable. Bring down the minus and replacing cosine squared with 1 minus sine squared. Again, that's a trig identity. And now I'm just going to get rid of my parentheses by distributing this -1. Okay, so that I can combine my like terms. So negative times 1 is -1. Negative times negative sine squared is positive sine squared theta. And then combine those sine squared plus sine squared, and I end up with 2 sine squared theta minus 1. Okay, so on that one, distribution is pretty quick because that is a difference of squares approach. But if you don't have a difference of squares approach like this one, part B, you have to write tangent theta plus 1 and rewrite it as tangent theta plus 1. In this scenario, what you're going to do is do like what we like to call for shorthand FOIL, to help you remember to multiply first, outer, inner, last. So we'll multiply first terms. So tangent times tangent, that's tangent squared theta. Then we'll multiply tangent times +1, because that's the outer term, and that's going to be positive or plus tangent theta. And then I'm going to multiply the inner terms. So 1 times tangent theta, that's another tangent theta. And then I multiply the last terms, so the +1 and the +1, so that's just a +1. So here you do multiply first, outer, inner, last. So bring down tangent squared theta plus 2 tangents, since this and this are like terms, and then the +1. So here, distribute all your terms. Okay? And that's it. That is day 2 notes. Thanks for watching.